Hi, everyone. We are going to discuss now the next part of our chapter 3, the methodology, which is the sampling procedure. As part of our methodology, we want to identify how many samples we are going to look into. So our objective for this session are the following. Objective number 1, we are going to define the meaning of sample. Second objective will be we identify the purpose of sampling. And the third one is to explain the stages of sampling procedure. And our last objective is to identify the types of sampling for quantitative research. Now let's look into the definition of sampling. One definition discusses that sampling is a process by choosing the respondents or subjects from a large population. We get sample sizes or samples to represent our population so that they will answer our survey questionnaires if we do survey research. Another definition of sampling is that it is the process of selecting a number of individuals for a study in such a way that the individuals represent the larger group from which they were selected. In this case, sampling will be the answer of the sampling will reflect the answer of the population. The entire population is involved, but for your research study, you choose only a part of the whole. Let's take note that it is expected that the samples will speak about the entire population because the samples represent the population where they belong. There are 3 elements of sampling procedure that we need to look into. The first one is population. A population is a term which means a big group of people from which or from where you choose your sample. For example, the total number of students officially enrolled in a school. It can be considered as a population. Then we will just get a sample of students who are going to be chosen to undergo our certain experiment or who will answer our survey questionnaires. Another example is that the total number of senior citizens living in a barangay or a number of out-of-school senior high school students or learners in a specific state or community or your barangay. So these populations is where our sample will come from. Another element of sampling procedure is the sampling frame. The sampling frame is the list of the members of the population to which you want to generalize or apply your findings about the sample. For example, the total enrollment of the school. There are lists of names that will come from the registrar. So here, it is where we are going to get our sample. It is the list where we are going to determine which will be undergoing the research process. The last element is the sampling unit. The sampling unit refers to every individual in the population. In this case of the school, each student is called as the sampling unit. What's the purpose of sampling? The sampling method has a main purpose to gather data about the population in order to make an inference that can be generalized to the population. Here, the concrete statement is that the sampling is needed so that we can minimize the resources that we are going to look into, that we are going to have for our research. Let's move on to the stages in the selection of a sample. There are 5 stages where we are able to select our sample. Step number 1 is to define the target population. The school, the community, friends, relatives. We need to identify based on what our research focus is. So we need to go back, or we need to look into our research problem or our research topic, because that is where we are able to find out what's our target population. And then we select a sampling frame. Since we already know what population we wanted to have, then we are going to look into the sampling frame. Then, step 3, determine if a probability or non-probability sampling will be chosen. Later, we are going to discuss the difference between a probability and non-probability sampling. The 4th step is that we need to plan the procedure for selecting sampling units and determine the sample size. The next discussions will proceed by discussing how we are able to distinguish the different sampling methods and how we calculate for the sample size. And the last step is that we select actual sampling units and we conduct our fieldwork or our research procedure. Let us take note that there are different factors that will affect the sample size. And here are some. Number 1, the sample size. Number 2, the sampling technique. Number 3, the heterogeneity of population. Number 4, the statistical technique. And number 5, the time and cost. We need to identify that these factors that we need to consider so that we are able to come up with the best procedure for our research. The sample size will be used. Why is it a main factor that will affect the sample size itself? Because there are a limit on whether the number of population that we are going to have should come up with a sample size. If we have a fewer number, for example, we only have a population of 15, then we don't need to come up with a sample size on this. Then there are also different sampling technique that we need to consider. Later, we are going to differentiate the 2 methods of sampling. When it comes to heterogeneity of population, we are going to look into on how we are able to distinguish the diversity of the population and how each of it will represent through the sampling selection. And let us take note that the statistical technique that we are going to use after we gather the data will greatly affect how we are able to come up with the sample size that we get from the sampling technique that we use. And the last factor is that the time and cost. There are sampling methods or sampling techniques that will take us a long period, and if we get too much or too many samples or sampling units, then it will cost us much on our field works or in the experimentation part or on the survey part. Now, let's look into the difference between the 2 sampling methods. There are 2 sampling methods, the probability and the non-probability sampling. The first one, the probability, is that it bases your selection on pure chance. Draw lots, lottery, these are probability. Non-probability sampling is that it chooses purposefully, not randomized and susceptible to bias. You will be the one to choose who will participate. You, the researcher, has the freedom to choose purposefully who will take the survey, who will be under an experiment. Now let's go deeper on the probability sampling. There are four methods of probability sampling. One is the simple random sampling. The second is the systematic sampling. The third is the stratified sampling. And the fourth one is the cluster sampling. The first one, the simple random sampling, is the one that choosing of respondents based on pure chance. So we use here lottery. We can use a fishbowl technique or through draw lots or dice. The advantage of this is it's easy to conduct and it has a high probability of achieving a representative sample. And it meets assumptions of many statistical procedures. But if there's advantage, there's also disadvantage. For the simple random sampling, one of the disadvantage of this is identification of all members of the population can be difficult because we don't know whether one will represent a one cluster or one section or the other. And contacting all members of the sample can be very difficult because you don't know which group does this particular sample that you have chosen came from, because you came up with a simple random sampling. You have your list of students, for example, and all of these students were arranged alphabetically, so you don't know their section. And then you draw according to the number of sample size that you have, and you don't know the section, and you are able not to contact it as soon as possible. So the time element is now being uh, considered. So there is a waste of time already. So when we conduct simple random sampling, we can follow this procedure. First, we identify and define the population. Then determine the desired sample size. Then list all members of the population. After that, you assign all members on the list a consecutive number. Then select an arbitrary starting point from a table of a random number and read the appropriate number of digits of respondents based on pure chance. You can do this electronically through Microsoft Excel or Google Sheet. You just need to fill in all the names of the students, then give them appropriate number. For example, you have 50 students, then all of these students will be numbered 1 to 50. Then you just need to click a randomizer. The next probability sampling is the systematic sampling. This is where you pick out from the list every fifth or eighth member listed in the sampling frame. Or you may choose from any number. For example, you wanted 10th to 15th, 10th or 15th, every 10th or every 15th. Then you need to replenish or release all the students from your sampling frame. Advantage of this is it's very easy to be done because you all have all the lists, and then you just need to pick every 5. So you just need 1, 2, 3, 4, 5. Oh, this participant will be our first sample. Then you count another 5, the second participant, and so on and so forth until you reach the desired number based on how you calculated your sample size. The disadvantage of this is it has a subgroups, and some members of the population don't have an equal chance of being included. So if we want to use systematic sampling, then we are able to follow these steps. First, identify and define the population, then determine the desired sample size, obtain a list of the population, and then determine what A or what number is equal to by dividing the size of the population by the desired sample size. Then you start at some random place in the population list. Then take every 8 or whichever number you have chosen individual on the list. For stratified sampling, it's choosing a sample that will later be subdivided into subgroups during the stage of the data analysis. An advantage of using a stratified sampling is that it is more accurate sample, that it will have more accurate sample. And it can be used for both proportional or non-proportional samples. And last advantage of stratified sampling is that representation of subgroups in the samples are evident. While for the disadvantage of stratified sampling, identification of all members of the population can be very difficult. And identifying members of all subgroups can also be difficult. How are we going to do the stratified sampling? So again, you identify and define the population and determine your desired sample size. And you identify the variable and subgroups, or what we call as strata, for which you want to guarantee appropriate representations. And then classify all members of the population as members of one of the identified subgroups. So you will just get a subgroup and a representative from that subgroup to be part of your sample size. So that's what we call as a stratified sampling. Then the last one is the cluster sampling, where we select respondents in cluster. Advantage of this is it's very useful when populations are large and spread over a large geographic region. And it's convenient and expedient, and do not need the names of everyone in the population. You just need a cluster. For example, you just need, if you are looking into a big school or a mega school, you just need to come up with 2, 3, 4 sections per year level. So you don't need to get all the list of names. You just need to get the number of sections. You just need 3 per year, then you get 3 per year level. So that's a cluster already. You're not going to choose one representative from each section that will be fall under stratified. But if you are looking into the cluster, then you get all participants from one section, another section, and another section. So that's a cluster. And disadvantage of this is that representation is likely to become an issue. Kasi pwede nating sabihin, we can say that sila yung napili kasi sila yung marurunong. Sila yung napili kasi sila yung mababait. Sila yung napili kasi sila yung maaasahan. So there will become an issue in terms of using the clustering or the cluster method or the cluster sampling method. So in order for us to use the cluster sampling, again, we identify and define the population and determine the desired sample size. We also identify and define the logical cluster. In such case, or if it's a school, then we use the sectioning. Then list all clusters that make up the population of clusters and estimate the average number of population members per cluster. Then you determine the number of clusters needed by dividing the sample size by the estimated size of a cluster. Then randomly select the needed numbers of clusters and include in the study all individuals in each selected cluster. So as I mentioned, you are not going to choose one, but you're going to include all who is part of the cluster. So that's for the probability sampling. Again, we have simple random, systematic, stratified and cluster sampling for probability sampling. For the non-probability sampling, we have three: quota, convenience, and purposive sampling. For quota sampling, it's you choose specific samples that you know correspond to the population in terms of characteristics. Disadvantage of this is that people who are less accessible are underrepresented. So here, in order for you to come up with your sampling, you are going to look into what you wanted to have as part of your research study. In the quota sampling, we just wanted to have a specific samples on the population. For example, you just wanted to have or to come up with only STEM students, and there are only few STEM students, so they will become part of the quota sampling. The next one is that the convenience sampling. The convenience sampling is picking who is easy to find out. Here, whoever is available, we can call also convenience sampling as the availability sampling. Whoever is available from the time that you want to have the conduction of the research or the experiment, then that's the one you're going to pick. The disadvantage of this is that the difficulty in determining how much of the effect, which is the dependent variable, results from the cause or the independent variable, because you don't know whether there is a right representation from the sample itself, because whoever is available, you just grab it and you already proceed to your, or you proceeded already to your experimentation, or you have already conducted the survey. Then the last non-probability sampling is the purposive sampling, where choosing respondents from you have judged as people with good background, or you already have a purpose why you are able to get these samples needed for your research. For example, you wanted to have only those students who are able to answer your questions properly, and or you wanted to come up with a study only for a particular set of group. And from those group, you're going to look into the samples that you already had a background check. The disadvantage of the purposive sampling is that potential for inaccuracy in the researcher's criteria and resulting of sample selection. And it's more on a bias sampling. Now, we look into on how we are able to calculate the sample size. So we are done looking into the two types of sampling method, the non-probability and the probability sampling. So if it's randomized, therefore it will fall under the research design experimental. If it's non-randomized, therefore it's the non-probability sampling, then it will fall under non-experimental type of research. So both non-experimental and experimental research need to have the sample size, because you are not going to come up with doing your experiment or doing your research with a big number of population. So let's take note that you are going to have to calculate for the sample size, so that you can only have a small portion which will represent the whole population. So with that, we can calculate the sample size through the use of the Slovin's formula. We have the Slovin's formula equal to n is equal, small letter n is equal to capital letter N divided by 1 plus NE squared. Here, N, small letter n, represents the sample size. The capital letter N is our population size. And E is the desired margin of error. It is the percentage of allowance for non-precision because of the use of the sample instead of the population. So here, we tend to manipulate whether we want if we are 100% sure, then that's a 0% margin of error. So the common thing that we use is the 5% of error or 2% margin of error. So we may use different percentages depending on what you wanted to have. For example, if the population for your research is 9,000 and the margin of error that you allow is 2%, what is the sample size needed in your study? Looking into the equation or the formula, can substitute the given values by n is equal to 9,000 divided by 1 plus 9,000 times 0.02 as the 2% margin of error squared. Then we can come up with 9,000 divided by 1 plus 3.6. With this, we can calculate already what will be our sample size. So if a 9,000 population needed for your research, then we could come up with a total sample size of 1,957 samples that will come from the population of your research. To summarize, there are two methods of sampling. We have probability sampling, which we have simple random, systematic, stratified, and cluster. And we have non-probability sampling with quota, convenience, and purposive sampling. And for us to calculate the sample size, we use the Sloven's formula. Thank you very much. I hope that you learned something from this discussion. See you again next time. Goodbye.